In this video, we will be looking at radians. Anytime you've measured an angle in the past, it's probably been in degrees, but there is another way to measure angles, and it is called radians. And radians are just a ratio of the arc length and the radius in a circle. So I'm just going to draw a little visual here. Say here's your circle, here's your center, and this is your radius. Let's say I want to measure this angle here. I will call that theta. The arc length is the distance from here to here, and we know what the radius is. It is the distance from the center to a point on the outside of the circle. So if I just create a ratio out of the arc length and the radius, that is another way I can measure the angle, and that is called your radians. So here is a little formula we can write out of that. Theta is equal to the arc length divided by the radius. Now, let's try to bring that into degrees and radians and see how they connect. Using this formula and using our prior knowledge of a circle, we know that the circumference, so the total distance or perimeter around the circle, is 2 pi r. So let's put that information in for the arc length. Let's say we're talking about a full circle, a full rotation. Well then, theta equals 2 pi r over r. So our arc length is the entire circumference. And if we're dealing with the entire circumference, we know the full angle in a circle is 360 degrees. So let's replace theta with 360. And now let's clean up. Well, the first thing, the radius cancels out very nicely because anything divided by itself is 1. So we're left with 360 degrees is equivalent to 2 pi radian, or rads. Let's clean up further. We can start off by dividing both sides by 2, and we see that 180 degrees is equivalent to pi radian, or 3.14 radian. Now let's say I wanted to know what 1 degree was equivalent to. Well, then I can just divide both sides by 180. That way, 180 divided by 180 is 1 degree, and 1 degree is equivalent to pi over 180 radian. And there we go. Now, if I were given an angle measurement in degrees, I can turn it into radians by multiplying it by pi over 180. Let's try to see the opposite. I'm going to go back to my statement, 180 degrees equals pi radians. Now, let's say I want to see what 1 radian was equivalent to. Well, in that case, I'm going to divide both sides by pi. And now I see 180 degrees divided by pi is equal to 1 radian. And if I were given an angle measurement in rad, then I can multiply it by 180 degrees over pi to figure out the number of degrees. And here are the rules we just came up with. So let's put them into practice. We're going to take each of our degrees and convert them into the radian measure. We already know from above that 1 degree is equal to pi over 180. So that's exactly what we're going to multiply by. And when we do this, we do need to clean up a little bit because we want to keep it an exact measurement. So when I look at this, I see 12, I see 18 because the zeros can cancel out, and 12 and 18 are both divisible by 6. So I can divide both numbers by 60. 120 divided by 60 is 2. 180 divided by 60 is 3. So we're left with 2 pi over 3 rads. let's try the next. Again, we're going to multiply by pi over 180. 210 and 180, we can ignore the zeros temporarily. 21 and 18 are both divisible by 3, so let's divide these numbers by 30. 210 divided by 30 is 7. 180 divided by 30 is 6. And we're left with 7 pi over 6 rads. Finally, 45 degrees, exact same idea. Both divisible by 45. And we end with pi over 4 radians. And there we go. Let's go in the opposite direction. We're going to convert from radians to degrees. So we're going to multiply by the opposite, which is 180 over pi. Now in this scenario, you can just do the multiplication of your numerator, so 5 times 180, and divide by 3. And if you're lucky, you get a nice number. The pi's do cancel out because you have 1 in the numerator, 1 in the denominator. So when I do this, I do in fact just get 300 degrees. Same thing for the next one, 180 over pi. The pi's cancel out. If you clean up your coefficients, you have 180 and 3. When we divide those, that is just 60 degrees. And finally, for the last one, there is no pi to cancel out in the numerator with the 1 in the denominator. So if we were to just clean this multiplication up, numerator times numerator, denominator times denominator, there's the exact answer. The rounded is approximately 229 degrees. So those are some examples to convert between degrees and radians. I'm going to do a final example here where we're using that arc length formula. So a circular cake has a radius of 20 centimeters. So R is 20. The first slice I cut has an angle of pi over 6 rads. So that's our theta. Determine the arc length of the slice. So we are looking for A. So I'm going to use our theta equals arc length over radius. I'm going to plug in the information that we have. So instead of theta, I'll put pi over 6. I don't know the arc length, and I know the radius is 20. At this point, I'm just going to do a little bit of cross multiplication. So 20 times pi equals 6a. And then we can divide both sides by 6 to isolate for a. And I am just going to reduce that 20 over 6 to 10 over 3. And there's our arc length for our slice. Therefore, the slice has an arc length of 10 pi over 3 centimeters. So just to recap quickly here, if you are converting from radians to degrees, because 1 radian is equivalent to 180 degrees over pi, we can multiply by 180 degrees over pi. When we want to convert from degrees into radians, we know 1 degree is equal to pi over 180, so we can multiply our degrees by pi over 180. Now, a little trick to remember this is your degrees, your angle, will be in degrees. Your denominator here is in degrees. So if you have degrees in the numerator, degrees in the denominator, that will cancel it out to bring that unitless radians measure. And then you can do the exact opposite. When you want to go from radians to degrees, we want to bring the degrees back into the picture. We want to bring those units back in.